Hello students, in chapter 7, welcome again. In definite integration part, students, today continue the third property. Yes, some properties of definite integrations. First I explained already basic fundamental rule. Second, assumption method. And third, there is some properties of definite integrations. It means students, it is legal theorem. There are total 8 theorems. Just be one by one going that. First of all, a to b fx dx is equal to a to b f t dt. Same function, same limit, answer same coming. If you write down here also, this also true. A to b f y dy, either f z dz, all are same coming answers. So whenever you function same, only variable change inside, limit same, answer must be same. Second property, a to b fx dx minus carry outside, so limit direction change a to b, b to a. I mean lower and upper change upper and lower. And if you both upper and lower limit are same, answer become 0. Next, third, a to b, you going in the partitions a to c and c to b. Look at that. You have to here a to b. You make the partition with the any one constant between necessary number. Yes, between its number. So a to b, just like converted a to c, and next of the b to c. Yes, students. So there are two partitions. So it is a continuity must be a to c and c to b. Sometime you also taking here 4 directions. A to c, c to d, d to b. That also true. More than 2 also connected. C, D, E, F. Now next, main important 4th and 5th theorem here. A to b fx dx, answer is f of a plus b minus x dx. It means upper limit plus lower limit minus x. Here also same, 0 to a same, upper plus lower minus x. Again repeat, upper limit plus lower limit minus x. In place of x, I replace then 4 and 5 theorems utilizations. You just only write down that in your notebook, and after that I explain numericals. Next, 6th one, 0 to 2a means 0 to a and again a to 2a, 2 parts. So one part is 0 to fx dx, other also same 0 to a, but f of 2a minus x dx. And 7th one, students, 6 and 7 are same. If you 2a minus x are replace fx here, this replace fx here, you can get fx and fx. Your answer is 2 times fx 0 to a. And if you 2a minus x is equal to minus fx replace here, so minus fx and plus fx cutting there, your result become 0. Yes, students. So here are 6 and 7 also theorem. Here we not need to proving this all theorem. Only you can by heart this property. Now continue 8. 8 also most IMP related your MCQ level questions asking related your even either or. So one of the f is even function. It means f of minus x is equal to fx, then minus a to a. This must be minus a to a means minus 1 to 1, minus 2 to 2, minus 3 to 3, minus pi by 2 to plus pi by 2. Opposite limits both are. Then your answer is 2 times, because these your limits minus a to a. There are 2 partitions, but one partition and second partition both even. So there are 2 times 0 to a. Either minus a to 0 is also correct. And last one, f is odd functions. Same property minus a to a in the domain of df. Then f of minus x is equal to minus fx. This property is what? Odd function. So your answer is, students, only and only 0 here. If you odd them and if you even function, then your answer 2 times 0 to fx dx. Yes, students, here only this basic property all 8 I just slowly explaining, not here proofing explaining. I again repeat, proofing is not required in this chapter. You just only write down that, and after that I start little numerical, students. Now students, we going ahead. Example 31. It is most time numerical in modulus x cube minus x dx minus 1 to 2. Yes, this is a IMP level numerical. First of all, you create here factorizations. Again further factorizations and try to plotting on this number line. Your range minus 1 to 2. You just think about this equal to 0, then x equal to 0. This equal to 0, then x equal to minus 1, already present here, and x equal to 1. Now you can take the directions between that, all three parts. First part, minus 1 to 0. Second, 0 to 1. Third, 1 to 2. And check the conditions. I check first this level. X plus 1 and x minus 1. So x is minus 1 to 0, already present there, negative. Second, I want to x plus 1. 1 adding. So it is 0 to 1. And third, I prepare x minus 1. So students, here minus 1. It get minus 2 to minus 1. So here students, you check x plus 1, x minus 1. This x is what? Negative. X plus 1 is what? Positive. X minus 1 is what? Negative. Finally, how much? Positive. It means here value is positive. Other alternate, definitely. I explained, don't worry. So my data x cube minus x, which is positive x cube minus x. Now here 0 to 1, already x. This x ready. Now I prepare x plus 1. So plus 1, plus 1. You can get here numbers in positive. Again I explain, but I want to now x minus 1. So students, minus 2. It means x plus 1, x minus 1. Your data is a positive. X plus 1 is a positive. X minus 1 is a negative. Total negative. It means modulus, you can get minus answer in this solution. And third one is also positive coming. Check. 1 to 2. Positive number. Now I create x plus 1. It get 2 to 3. And also if I converting into x minus 1, check here. It get 0 to 1. All number positive. So x plus 1, x minus 1. It get positive, positive, positive. Permanently positive. This condition, students, necessary first you understood. Now I start my sum. Integration minus 1 to 2 x cube minus x dx. First, minus 1 to 0. Second, 0 to 1. Third, 1 to 2. There are 3 total partitions wise. This is already theorem. And these values, students, first already I convert x cube minus x. Secondly, minus carry outside, x cube minus x. And third, this is also positive. So this answer, students, I just remaining, don't worry. It is x cube minus x because positive will be modulus. In your textbook, direct given. So I hope you understood this condition. Now my answer ready. 4 by 4 square by 2. Here minus x raised to 4 by 4 square by 2. Limit 0 to 1. And last here x cube by 4 by 4 and square by 2. Limit 1 to 2. Here 0 to 1 and here minus 1 to 0. Now apply successfully. 0 minus 0 upper limit. Now lower limit 1/4 minus 1/2. This done. Now here minus common carry outside. So indirectly both plus upper limit put it. 1 by 4 plus 1 by 2. Minus carry outside 1 by 4 1 by 2 upper. 0 putting the no value. Next. Here 2 square. 2 raised to 4 16 and 4 by 2. And here 1 by 4 1 by 2. So indirectly my data is coming here. 1/4 minus 1/2. 1 minus 2 minus 1/4. 1 minus 2. Yes, minus 1/4. Here students 1 plus 2 3 by 4. That cancel. 4's 4's are 4. 2 2 4's are, it means 2. And here again 1/4 minus 2 minus 1/4. So your data 1/4 minus 3/4. Yes, plus 2 plus 1/4. 1/4 and 1/4 and 3/4 all are combined taking. So 2 plus 1/4 1/4 3/4. So 2 plus here 1 1 and minus 3. How much? 1 minus 2 minus 4. Yes, it gets student here. Our solutions coming, and after that you calculate value. Now students, in these solutions I think here my one mistakes. Minus as it is, this minus and this minus, here plus students. So I just here minus write down, this plus same as. Now here take the calculations. So here minus 1 plus 2, it is 1/4 actually. So that is also 1/4. 1/4 1/4 and 1/4. It is students 3/4 plus 2. So 3 plus 8 by 4. Now it is 11 by 4. So one my little mistakes here, minus minus plus, and then after students we doing your solutions. Now continue our example number 32 students. Similarly going integration of in the 32 minus pi by 4 to pi by 4 sin square x. Yes, sin square x dx. Here also students minus a to a related, our 8th theorem. You check first a given function odd or even, just replace in place of x minus x. It is minus square, it means plus, and it is a fx. It means given fx is even function. It means my numericals is minus 45 to 45 be divided into two partitions. One of the minus 45 to 0 or other 0 to 45. Two times I just write down that 0 to pi by 4 and another sin square x dx same as. Now I going to answers. So 0 to pi by 4 1 minus cos 2x by 2 to cancel, and here you can try your integrations, and after that students limit putting. Very easily you create your answers. So it is your x, that is sin 2x by 2 coefficients 0 to pi by 4. So pi by 4 minus 2 into pi by 4 by 2 minus 0 putting then corbidly 0. This also cancel. So my answer is a pi by 4 sin 91 by 2. And here students, very easily and happily this example also students completed. Now example 33. This is the most IMP numericals, so you can highlight in IMP list. 0 to pi x sin x dx upon 1 plus cos square x. Yes students, I just question reading, don't worry. Statement 1. First of all, you think about, if you this x not given, it means I remove anyhow this x using theorem. Definitely other are cos x suggestion sin t dt, easily converted. So this converting x are removing, I just replace theorem number 4, upper limit plus lower limit minus x for x. So replace upper limit plus lower limit minus x for x. Again repeat, upper plus lower limit minus x. If you replace x, you apply your theorem number 4, either 5. So here you can get necessary this doing a pi minus x sin pi minus x, and here cos square pi minus x dx. Now pi minus x, which quadrant? Yes, second quadrant. So I is equal to 0 to pi minus x sin x, and here students 1 plus cos square x dx. Statement 2. Now 1 and 2 only you can add, you get easily further solutions. So students, I simple additions 2, 1 and 2. So we adding 1 plus 2. Now what is the 1 and 2? It is 2i. Other I have 0 to pi x sin x plus pi minus x sin x. Both LCM same, and 1 plus cos square x as it is. Again repeat, this LCM part and this LCM part both merge. So 2i 0 to pi x sin x pi sin x minus x sin x, and upon same as. So does this cancel permanently? Pi common check outside. Other you have to now check what is the remaining. So does this part you can read by this one. Definitely here x remove. Pi is extra coming, but now you can suggest cos xt sin x dx, and easily coming answer. But this factor if you converted only and only by replacing our theorem. Now very simple, assume cos xt sin x dx, I written here minus dt. Change the limits. If x tends to 0, then cos 0 1. If x tends to pi, cos pi minus 1. So my value is 2i, 0 putting then 1, but pi putting then minus 1. Here sin x dx, it is minus dt, and 1 plus cos square, which is t square. Now numerical over easily. Students, I is equal to minus pi by 2, and it get tan inverse t, and limit 1 to minus 1. Happily you putting 1 time tan inverse minus 1 upper limit minus lower limit. So your data is coming I minus pi by 2. It is minus 45. Here also. So it is a minus pi by 2. And total you getting pi square by 4. Pi and pi square, 2 to the 4. And this answer done here. Example 33. Now continue students. Example 34. Similarly doing ahead. It's very easy numerical. Minus 1 to 1 sin the 5 power but cos the 4 power. Students, minus 1 to 1 it means minus a to a related. It means our theorem, 8th theorem. Apply that and check first odd or even. Either replacing method is also true. I take odd even wise. Sin the 5 cos the 4. So what is the replacing minus in place of x? Minus x. Minus x. Yes, definitely. It is your minus and that plus. And sure it is minus fx. Now check the values. It is odd or even? Definitely it is odd function. It means I write down fx is odd function. So my answer I minus 1 to 1 sin the 5 cos the 4 is 0. Our theorem number 8. Yes, second property. Either you can apply by the replacing wise I and I to I, you get 0. But it's best way, so I apply by this rule. Now 35. Example, continue, going ahead. Integration of zero to pi by 2 sin the 4 cos the 4 and sin the 4 dx. Yes, 4 power d related. Students, this also very easy numerical. Here I take statement number 1. Start your theorem 4. We replace upper limit plus lower limit minus x for x. Again repeat, upper plus lower minus x. It means 90 minus x. So your I is 0 to pi by 2 sin raised to 4 90 minus x. That same 90 minus x, and here also same 90 minus x. So students, 90 minus x, it means sine converting in cos and cos in sine. It means you have to new I 0 to pi by 2 cos the 4 power sine the 4 power and here cos the 4 power. Statement 2. Check 1 and 2 both LCM are same. So we adding 1 and 2. So students, 2i 0 to pi by 2, one of the sine 4, another of the cos 4 dx, but internal cos 4 sine 4. Here sine 4 cos 4. You check your downwards and upwards are same. It means it is indirectly 1 coming. Sine 4 cos 4 by cos 4 sine 4 dx. So this cancel. And other easily your answer. We have to 2i 1 dx 0 to pi by 2. And it is your what? X. Now apply your value 90 minus 0. So your answer is finally pi by 4. Very easily coming. That type many numerical given in your book, students. Here 4 power, either 5, 6, 7, any. You create your answers. Now same as students, 36 examples. Same dicto, copy some. Integration 1 upon 1 plus under root 10x dx, and limit is given pi by 6 to pi by 3. Here also students, I just make in the, sorry, question wrong written, I pi by 6 to pi by 3. Here pi by 6, students. Here I am making first in sin cos, and you can take your LCM. So our I is become pi by 6 to pi by 3 root cos x, root sin x dx, and here you can take statement 1. Students, this numerical and that are totally same. Check here. We replace upper limit plus lower limit minus x for x. Actually it is coming 90. Pi by 3 plus pi by 6. So what you get, I pi by 6 to pi by 3. Here root cos. Here root cos. And here also root sin dx. Actually if you 90 minus convert it, you can get here students pi by 6 to pi by 3. It is your two values. One kind of sin x, cos x, here also sin x, and here cos x. Statement 2. Now same, if you adding, you gain what? Here also adding, then you getting 1. Same sum, no? Yes. So after this students, I going ahead adding 1 and 2. It is 2i, and 0 to, sorry, not 0, pi by 6 to pi by 3 are same. Root cos x, root sin x. Downwards, root sin x, root cos x. And other same as this cancel, and that is exactly 1. Pi by 6 to pi by 3. So my answer is x, and limit I just putting down pi by 3 minus pi by 6, 60 minus 30, which is 30. So what is I? Pi by 12, and here are final answer for this example 36 students. Now 37, which is very most IMP numerical coming. Yes, 37. You tick mark in the IMP list. Very most many time asking in final exam. Integrations 0 to pi by 2 log with the sin x dx. Statement 1. Again I check 0 to pi by 2 log sin x dx. Yes students, process same. Replacing upper limit plus lower limit minus x for x. So we replace upper plus lower minus x for x. So your data is 0 to pi by 2. Here you can going values wise. Sin pi by 2 minus x. So what is your value? Your value is log of cos x. Now both we add them. We adding 1 plus 2, which is 2i. So 0 to pi by 2 log sin x log cos x. If you both added, students, then definitely you can get log of sin x into cos x into dx base e. Yes, students, here now one little turning point, and that you necessarily do, then you can get answer. So now I start here one turning point value, 2 multiplying and 2 dividing. So twice I, 0 to pi by 2 log, here 2 multiplying, necessary students, and 2 dividing. So it is getting sin 2x by 2, and here to separate log property, log m by log n, minus subtraction there. So twice I, 0 to pi by 2 log with the sin 2x minus log with the 2 dx. So you can get here log sin 2x dx minus log 2 1 dx. Limit same, 0 to pi by 2, 0 to pi by 2. So does these solutions I create after that, it is suggestion I1. Don't worry, like here I calculate, it is x 0 to pi by 2, and my solution ready in the halfway only, pi by 2 minus 0. These are 2i equal to I1 minus log 2 base e pi by 2. Now I start I1. Only I1 I now explain, and after that I ending my sum. So students, I start for only I1. I1 is what? 0 to 90 log sin 2x dx. Students, this 2x I just suggestion, assume 2x is t, 2 dx dt. What is dx? dt by 2, and change the limits. If x tends to 0, t tends to 2x, 2 into 0. If x tends to 90, t tends to 2 into 90, it is pi. Actually new limits coming whenever you suggestion. So my new limit in I1, 0 to pi log of sin t into, what is dx dt by 2. Look at that, these are your question. Limit 0 to 90, but I have to 0 to pi. So can we write down in partition? Yes, according to theorem. Third one, these and these are 2 times. So I just write down 2 times 0 to pi, dissolve in 2 parts, 0 to pi by 2. Other log sin dt by 2. Actually students, this I1 is actually I. Check this, same as that, only that is dx and here dt. Now this I1 I apply here, and you can get your answer. So 2i is equal to I1 minus log 2 base e into pi by 2, 2i minus this I. I1 is I, already I proved, pi by 2. So my answer is I is equal to 2i minus I minus log 2 base e pi by 2. And here students, your final answer. Yes, this is the most IMP numerical for example students 37 wise. Now after that students, I start my exercise. Yes, here example done. So now I slowly going our exercise. Yes, 7.11. First one, integration 0 to 90 cos square x dx. Yes, very easy. Cos square x formula apply. Either replace, I going a replace wise. We replace upper limit plus lower limit minus x for x. So you can get only it is 90 minus. So cos square 90 minus x dx. It is sin square x. But 0 to 90. Statement 2. Now 1 and 2 both addition. So we adding 1 plus 2. Students, 2i cos square x plus sin square x. Either you can operate the property cos square x 1 plus cos 2x by 2, same coming, and here students only 1, 0 to pi by 2, it is x 0 to pi by 2. So my answer is 2i 90 minus 0. So what is the I? Pi by 4. And here students, you finally this answer. First question easily done. Now students, after ending we going that next some numerical, second one. Now they all are same pattern students and easy numericals, so you can easily complete it that in simple way. So my question 2 is integration of 0 to pi by 2 under root sin x, under root sin, and the under root cos x dx. Students, here you can write down statement number 1 and you start easily. We replace upper plus lower minus x for the x. So what's your I? 0 to pi by 2. Here I can write down sin 90 minus x, same sin 90 minus x, and same cos 90 minus x. Actually 90 minus x is what? Cos, converting sin, and sin converting in the cos. So here you get 3 types of data. 1 cos x, here cos x, that sin x. Statement 2. Now 1 and 2 adding. So we adding 1 in 2. Surely students check your downwards are same. So can we write down directly addition? Yes. Root sin, root cos, root sin dx, and it is permanently cutting. So my answer 2i 1 dx 0 to pi by 2. So students, 2i it is x 0 to pi by 2. So my answer is finally done. Pi by 2 minus 0 pi by 4, and this happily easily done. Now continue students, question number 3rd. Similarly going only power change. Integration 0 to pi by 2 sin below cos with sin, and polarity given students, it is a 3 by 2. Yes, I only question right, don't worry students. This 3 by 2 and it is half, indirectly both numerical are same. Yes, means answer is same coming up, pi by 4. That take you statement number 1. So we replace upper plus lower minus x for x. We are replacing upper limit plus lower limit minus x for x. So what you get, I 0 to pi by 2 sine 3 by 2 90 minus x cos 3 by 2 90 minus x sine 3 by 2 90 minus x. So your data is converting indirectly cos raised to 3 by 2x. Here sine raised to 3 by 2, cos raised to 3 by 2. That is statement number 2. Now 1 and 2 addition. So we adding 1 plus 2. So 2i 0 to pi by 2 and your LCM is same. Downwards, upwards same. Your answer is sine raised to 3 by 2 cos raised to 3 by 2. Here also sine raised to 3 by 2 cos raised to 3 by 2. So does this and that LCM same I declare and this cancel. I have only 1 dx 0 to pi by 2. Now one integration 2y equal to x 0 to pi by 2 same. So my answer is, students, pi by 2 minus 0. Your answer pi by 4. And here, students, finally third and second, check that. Similarly all steps are same. It means here any power given you can create by same method that type of solutions. Next, question number 4. 4 also same numericals, 0 to pi by 2, and my question is that cos the phi power, here sin the phi power and cos the phi power. Here take statement 1 and you try this numerical itself. I give you this numerical homework. Same as this pattern, you can get answer, students. What? Pi by 4. So fourth numerical I give you today homework, and fifth I start. Yes, fifth is a minus phi to phi in modulus. This is the IMP question. Huh? Yes, in modulus minus phi to phi in the x plus 2 dx. Students, whenever your modulus is given, then yes, you create the partitions minus phi to phi, and this term equal to 0, taking x is equal to minus 2. One this direction, another this. So my condition minus phi to minus 2 and another minus 2 to phi. So I want to x plus 2. So students, here plus 2 adding, systematically plus 2 adding, you getting here minus 3, you are getting 0. It means this answer, students, purely negative. Check. So I just write down modulus x plus 2, which is negative x plus 2, and here also I can write down plus 2. So you can get 0, but that's 7. This is also purely positive. So x plus 2 is equal to positive x plus 2. Now your integration, students, you easily start by parts, one by one in two partitions, one of the negative and one of the positive. So here, students, integration I can take here minus phi to phi modulus x plus 2 dx, one kind of minus phi to minus 2, and another minus 2 to phi, and indirectly here this answer is negative, students. and that is positive. Are you clear why negative? This condition wise. Now I take integrations. Square by 2 to x, minus 5 to minus 2, and here same, x square by 2 to x, minus 2 to 5. So my answer is ready now, and calculation is easily. Minus 2 the square means 4 by 2, 2 to the 4. Minus 5 putting, 25 by 2, 5 to the 10. And next, 45 by 2, 5 to the 10. And minus 2 putting then, 4 by 2, 2 to the 4. It means 2 to cancel. You have to minus 2, minus 25 by 2, plus 10. And that is, students, plus 25 by 2 plus 10. This cancel 2. It means minus 2. So minus take inside. 2, 25 by 2, minus 10. 25 by 2, 10 in plus 2. So 10, 10 gone. 2 and 2, which is 4. And here 2 times 25 by 2. 1 time. 1 time. And students, here 25 by 2, 25 by 2, 2 times this cancel. So my answer is 4 plus 25. It is 29. And here students, your 29s is correctly and easily answers over that in this part. Yes students, now this part I stop here, and further explanations continue to in this property wise theorems I explain you in the next part. Okay students, bye bye.